All right, so we're continuing section 13.1, working on some exercises. We're on page 823. And we'll start with number 24. In exercises 24 through 32, sketch the graph of the equation. So 24, they give us z equals 2. And remember when, now I don't see x and y show up there, so that tells us x and y take on every value. So we're stuck at z equals 2, and then we go take on every value, every x value and every y value. So this is going to give us a plane. Now we could tell from that equation that this was an equation of a plane because we're familiar with planes, and you could rewrite this as 0x plus 0y plus z equals 2 to see that that's a plane with normal vector 0, 0, 1. So to sketch this, all we would do, it's just going to look like the XY plane just shifted up. So remember, it'll be kind of be hit or miss with which planes we opt to sketch and which ones we don't, just because some of them really can't tell what they look like from the sketch. So probably the easiest way to do this is just do that, and this is 2 right there. So we'll just get this plane. It's parallel to the XY plane, because x takes on every value and y takes on every value. And remember, no arrows. It's just understood that this thing goes on forever. Now we will encounter problems where we might just want to sketch this portion of the plane, but normally when we do that later on in the course, we're going to be doing that in the XY plane. So there will be no ambiguity there as to what we're discussing. All right, so next let's look at number 38. Number 38 says in exercises 38 through 55, sketch the quadric surface. Okay, so after we do a couple of sketches of these, I'll refer you all to some quadric surface equations. A quadric surface is just the analog to a conic section. So in previous classes, you all would have learned about ellipses and hyperbola. So in here, the analog to conic sections is quadric surfaces. So, and we'll have a list of them. We'll have ellipsoid, hyperboloid. You all have seen some of them in our sketches already, but the textbook kind of shows pictures and lists the equations for all of them on the last couple of pages of section 13.1. So we are sketching x squared over 4 plus y squared plus z squared over 9 equals 1. And because they told us it's a quadric surface, if you want to, you can go and refer to the equations and pictures and names on pages 821 and 823 to figure out what this is. We're just going to sketch it the same way we've been sketching everything else. So we're going to start with traces and figure it out that way. So first, we'll sketch traces. We're going to do x equals 0, y equals 0, and z equals 0. Let's see. So x equals 0. What we'll get is y squared plus z squared over 9 equals 1. Y squared plus z squared over 9 equals 1. And that is an ellipse. Let's just sketch that ellipse here. And whatever has the bigger number at the bottom, so this has a 1 in the denominator, that has a 9 in the denominator. Whatever has a bigger number in the denominator is going to be elongated in that direction, or you still always can just plug in y equals 0 and see you're going to get z equals plus or minus 3. And when you plug z equals 0, you're going to get y equals plus or minus 1. So y, z, but we don't need to know those actual values though. So that's what we're going to get there. Then let's do the trace y equals 0. And when we do that, we're going to x squared over 4 plus z squared over 9 equals 1. Which is also an ellipse. And of course, it actually should look different than that one, but we're just trying to get an idea of the shape. We don't need the specifics of it. These ellipses. All right. Now let's do z equals 0. And for that one, we have x squared over 4 plus y squared equals 1, which again is an ellipse. This one will look like that. All right, so looks like no matter which direction we look at this, or which way we look at whatever this three-dimensional thing is, it's going to look like an ellipse. So when you have ellipses, in all traces gives an ellipsoid. So that's what our 3D image is going to be, is what's called an ellipsoid. So now let's sketch that. Go to the next page. And although I'm not a stickler about it at all, I will try to elongate this thing in the proper directions. So this is x. And if I look at our traces, it was elongated in the xy plane, it was elongated in the x direction, and then, okay. So it would look, so to sketch this, you're just going to sketch one ellipse in the xy plane, or you could sketch, if you wanted to, you could sketch it in the YZ, one ellipse in the YZ plane. It doesn't matter, either one is fine. I just tend to sketch it in the XY plane. So I'll sketch an ellipse here. Now when I sketch this ellipse, I'm going to, the back of it, I'm going to make a dotted line. And then from there, I'm just going to make one big ellipse that like touches at the end of these, at the end of this one, excuse me. So let's make it go up to here and down to, I don't know, about right there. I don't think I went down far enough, but all right, so it looks something like that. And this is what's called an ellipsoid. All right, so next, let's look at what number do I have listed next? Number 54. So number 54 says, so same directions, we're sketching the quadric surface. And for 54, we are given z squared minus 4y squared minus x squared equals 1. So you all should go through those equations for quadric surfaces and see if you can figure out what this is from those equations, and we'll go through and we'll sketch traces together to figure out what it is using traces. All right, so trace x equals 0, and I normally start off with trying to trace x equals 0, y equals 0, z equals 0. If I don't get any useful information from that, then I switch gears and I look at something, some non-zero value. So for the trace x equals 0, we're going to get z squared minus 4y squared equals 1. So z squared minus 4y squared equals 1. And this is going to give us a hyperbola. And don't worry about like the specifics of the hyperbola, other than you'll look at where, well, once I'll show you how to kind of figure this out this way, because there are a lot of ins and outs of trying to figure out what a hyperbola looks like, but we're just doing very basic. Oops, can't squeeze in my c-axis up there. All right, so just take, you can just take a value, and normally I just use 0 and plug it in and figure out which way this thing is going to open. So say for instance I did, and I know this is not going to work, but if I did z equals 0, if I did z equals 0, then I get negative 4y squared equals 1, which I get this negative number, which I know negative 4y squared is always negative equals a positive number. So it's impossible for z to be 0. So now we know z is never going to be 0. I can't have anything on my y-axis. So that tells me, now if you wanted to, you could look at when y is 0, you get z is plus or minus 1. So I'm going to be whatever there and there. But as soon as I know that z could not be 0, I knew my hyperbola was going to look something like this. All right, and that's basically all we'll need to know for that. Now let's look at the trace y equals 0. And there we're going to get z squared minus x squared equals 1. Oh, sorry. How do you identify that this thing is hyperbola? I forgot about that. So you have two variables being squared, and they have opposite signs to one another, and then it's equal. They're on one side together and have opposite sides, and then it's equal to 1. You might have some other non-zero constant over here, but say I had 3, then I divide everything through by 3, and I would have equal 1 over there. So because I have the difference of squares equals a constant, I know that I have a hyperbola. So this is also going to be a hyperbola. So here, Same thing, z equals 0 won't work, so I know that this thing's going to look like this. All right, now let's look at another trace, and because I always try something equals 0. Here I can see though quickly, if I try z equals 0, I'm going to run into an issue because this left side is going to be negative and the right side is positive. So a z can never be 0. So I can't use that for my trace this time, even though I normally would start there. So let me do something else. And it doesn't matter. Let's say if we do let's do z equals 2. We probably should have done z equals 1. I don't know why I picked 2, but we'll go for it. So z equals 2. So when we do z equals 2, what are we going to get? We're going to get 4 minus 4y squared minus x squared equals 1. So if I move that 4 over to the right side, then I get negative 4y squared minus x squared equals negative 3. So now what I want to do is try to figure out what this is. So I'm going to try to put it in some familiar conic section form. So is it a parabola? Is it an ellipse? Is it a hyperbola? So because I have two square terms in there, I know it's going to either be an ellipse or a hyperbola, but they have the same sign. The fact that they have the same sign tells me it's going to be an ellipse. Now, given that's negative, so we're just going to divide everything through by negative 3. So when we divide everything through by negative 3, we're going to get 4/3 y squared plus x squared over 3 equals 1, which gives us an ellipse. So now, and in one of our other videos, I drew the trace in its actual plane. If I wanted to, I could actually put this in, instead of putting in the plane z equals 2, I could put in the plane z equals 0, and then it would actually be a level curve instead of a trace. So this is x, y, and this would actually be called a level curve. Now, if I put it in the actual xy plane, and I meant to mention that for another problem, so I'll specify what how you could determine what the level curves would look like for this problem to make the level curves a little more clear. All right, so here we have an ellipse. And again, don't worry too much about how that thing's going to look. There are some ways I can figure out from this kind of how that's going to be set up, but I'm not too concerned with that. So now we're going to take these three traces and we're going to put them together, and we see if we look, if we're like on the x-axis and we look at it, it's going to look like a hyperbola. Then this is when we put it in 3 dimensions. If we were on the y-axis and we look at it, it's going to look like a hyperbola. But if we're on the z-axis and we look at the figure, it's going to look like an ellipse. So let's see if we can put those 3 things together. So you all probably have already figured out what this is by name from looking in the textbook at the conic sections. And of course know what it's going to look like as well, because they have pictures in there to go along with them. All right, so I'm just going to sketch a hyperbola, whatever in the YZ plane. So the ellipse we're going to have is actually elongated in the x direction, so I could sketch that first if we wanted a more accurate sketch, but I'm not going to do that this time. I did that for one other problem, but I don't want you all thinking that I would be a stickler about that, because I would not. All right, so we have that. And then now I'm going to sketch the ellipse up here. And because my sketch is not that accurate, my ellipse just ends up looking like a circle, which is fine. And I'm going to sketch one down here. And we end up getting a hyperboloid of 2 sheets. So we get hyperboloid of 2 sheets. And I'm going to say along the z-axis. So in those equations that are in your all's textbook, when you switch around, you can switch around the order of the variables or where the variables lie, and you're still going to get, it's still going to have the same name. It might just change in where we might have had the hyperbola of 2 sheets that was like along the y-axis instead. So one would have been over here and one would have been over there. But the equations are going to look similar. It's just the placing of the variables is slightly different. Now, I mentioned I wanted to talk a little bit more about level curves here, and this is probably as decent of an example as any to talk about level curves. So if I wanted to sketch the level curves, which our problem didn't ask us to do this, but if I wanted to sketch some level curves, and we did this already. We talked about level curves, but not for some surface. So say, for instance, I wanted to do the level curves. And remember, level curves, you don't get the, actually, can I do them for this one? I can. But for level curves, you don't get the option of which variables to use as you do with traces. So traces is like x equals 0, y equals 0, z equals 0. So for level curve, we take whatever our function is. And actually in this scenario, I don't have a function, but I'm going to use z. We use z for our level curves. So I'm going to use z, and I'm going to put in values for z and then sketch those curves. But your level curves are all sketched in the xy plane on one set of axes. So I'm going to do that for this particular problem. And our z here, let's see. And for this one, now you all have seen me go through and calculate level curves in a previous lecture. This one, I'm not going to go through the calculations. We're just going to use our intuition in that picture that we have up above. Let's see what it would, so now, as if z is positive, as z gets larger, and we slice through this figure in whatever z values, the ellipses get larger. If z is negative, and we slice through this figure, then as we go down, the ellipses get larger. As we go up, they get smaller. But of course, at a certain point, it wouldn't be defined at all. So let's say we take, we did z equals 2, and we got an ellipse. So let's just say it was this ellipse for z equals 2. So I'm just going to draw a curve here. I'm going to make sure I put a 2 in there to indicate it's a level curve where z equals 2. And it's understood that that's your z value whenever you're doing level curves. And then I'll do another one. As z goes up, and this will be z equals 3. So if I do z equals 3, but notice I'm going to also put on this same one -3, because as z equals -3, it's also going to, the ellipse is also going to look like that. And I can do z equals 4. Or -4. So the ellipse is going to look like that at 4 and -4. So your level curves, you just put them all in one set of coordinate axes. And then basically what you're saying is, what does my graph look like? Now, normally we would go in order like 2, 3, 4 and leave the negative one off. So you can imagine then taking these and pulling them out to the different heights. The 4 one, I would pull up to 4 units. The 3 one, I would pull up 3 units. The 2 one, I would pull up 2 units. And they would start to stack to look like this. So that's one of the uses of level curves. All right, so I'll stop this video here and then we'll conclude section 13.1 in our next video.